Okay, so this is from chapter 3, my reassessment of Newton's second law. It's number 50. It says that we have a particle, constant acceleration, north. So this would be the vector for the acceleration at t equals 0. The velocity vector saying 60 meters per second east, and it wants to know at what time will the magnitude of the velocity be 100 meters per second. Okay, so first we need to find our velocity final in the x direction. So we have 60 meters per second east. We put that into our equation, times time, from initial to well, we don't know, so we just we get 60 meters per second. We go to in the y direction. Okay, so we know the acceleration. There is no velocity, so we all we can go by is time, which it's given. It's asking at what time. So we have to keep our t in the equation. Velocity final. We need to use our Pythagorean theorem. I'm sorry, not Pythagorean theorem. We can. This is how we can put our x and y together. I'm not too good at explaining my math. I just I understand how it works. It's probably one of the more difficult ways to explain the problem, but it's the only way that I get it in math terms. So we're given the final magnitude would be 100 meters per second, which is this is going to be where this is. So we're going to say this. We're going to take away our square root. Because we take away our square root, we can also think about how these numbers can be translated. You can say 60 meters per second squared, or you can say, because when you really think about what acceleration is, and well, no, that's right. Whenever you think about what acceleration is, we can say it's 3,600 meters squared per second squared. And same goes for what we do to one side, we have to do to the other side. So we have 10,000 meters squared per second squared. This can also so then we can move this over to this side. So we know we have 64 meters squared per second squared. And then we can unsquare these on both sides, moves us back down to 80 meters per second. And all we're left with is our acceleration and our time. We solve for time. We get 0.8 seconds. Like I said, I'm not that good at explaining my math steps, but I hope they're clearly written, because that's the best way that I could, I guess, figure it out mathematically. All right, thank you.